Tonight, if the sky's clear, you can look up and find a star with your own eyes. One among billions, another point of light, doing exactly what stars are supposed to do. Somewhere out there is a star that is not supposed to exist at all. Not because it is too big or too bright or too strange to look at, because of its age. When astronomers finally calculated how old this star really is, the number that came back was older than the universe itself. Not close, not roughly the same. Older? The real answer to how that is even possible is far stranger than a simple measuring mistake. It touches the very foundations of how you think time, matter, and the universe itself began. Here is the star. It is called HD 140283, though almost everyone who has written about it since just calls it the Methuselah star, after the biblical figure said to have lived 969 years. It sits a little over 190 light-years from Earth, visible with a decent backyard telescope, unremarkable to look at. No supernova, no collapsing core, just a modest, aging star, drifting quietly through the constellation Libra. Astronomers have actually known something was odd about this star for decades. In the 1950s, astronomer Alan Sandage studied its motion across the sky and noticed it was moving unusually fast compared to nearby stars, a telltale sign of an ancient object that formed before the galaxy had settled into its current shape. Fast-moving old stars like this one are sometimes called stellar fossils because their motion alone hints at billions of years of history. But motion is not the same as an exact age. To actually calculate how old a star is, astronomers rely on something called metallicity, the amount of heavier elements packed inside a star compared to hydrogen and helium. Here is the part that always needs decoding. When astronomers say metals, they do not just mean iron and gold. They mean almost every element heavier than helium, including oxygen, carbon, and calcium. And nearly all of those heavier elements were forged inside earlier generations of stars and scattered into space when those stars died. Why does that matter so much? Because the very first stars that formed after the Big Bang were built almost entirely from hydrogen and helium. There was nothing heavier around yet to build them with. Every generation of stars born afterward inherited a little more metal from the stars that came before, recycled from stellar explosions, like ingredients passed down through a cosmic kitchen. A star with almost no metal content is a star built from some of the oldest, rawest material in the universe, and HD 140283 has almost none. So how do you turn low metal content into an actual number? Astronomers use something called stellar evolution modeling. It sounds complicated, but the idea is simple. Stars change brightness and color in extremely predictable ways as they burn through their fuel over billions of years, almost like a candle that changes shape and color as it melts down. If you know how bright a star truly is, how hot it burns, and how much metal it contains, you can calculate with real precision how far along that burning process it already is. This is exactly what a team led by astronomer Howard Bond set out to measure in 2013 using the Hubble Space Telescope. Hubble allowed the team to measure the star's true distance from Earth with far more precision than ground telescopes ever could, using a technique called parallax, essentially watching how the star appears to shift position as Earth orbits the Sun, the same way your finger seems to jump left and right when you look at it with one eye closed and then the other. Once they nailed down the true distance, they could calculate the star's actual brightness, and from there, plug it into the stellar evolution models. The number that came back was 14.46 billion years old, give or take about 800 million years. Here is the twist that makes this genuinely dizzying. The universe itself, according to the best current measurements from missions studying the cosmic microwave background, the faint afterglow of the Big Bang, is about 13.8 billion years old. A star older than the universe it exists inside of is not a small discrepancy. It is a direct contradiction. Either the age of the universe was wrong, the age of the star was wrong, or something in the models connecting the two needed a serious second look. So what actually happened next is the quiet, unglamorous part of science that rarely makes headlines. Astronomers did not throw out the Big Bang. They went back and tightened the uncertainty in their measurements. The margin of error on the star's age, that plus or minus 800 million years, was large enough that the star's true age could sit comfortably at 13.7 billion years, just slightly younger than the universe itself, once every source of measurement uncertainty was accounted for. In other words, the paradox was not a crack in the fabric of cosmology. It was a reminder of how thin the margin really is when you are trying to measure something across nearly the entire history is a snapshot of the universe, before most of the raw material that makes up you had even been created yet. You are, in a very real sense, made of leftovers from stellar generations. This fossil star never had the chance to be built from. And this changes the way you should think about looking up at the night sky. Every point of light up there is not just distant. It is a different chapter of time itself, some barely older than your own lifetime, others carrying the faint imprint of a universe still in its infancy. You are not just looking across space. You are looking across billions of years of cosmic inheritance, all arriving in your eyes at once, all at the same moment, as if none of that time had passed at all. Tonight, if the sky is clear, you can look up and find a star with your own eyes, one among billions, another point of light, doing exactly what stars are supposed to do. Now you know that somewhere out there, one of those points of light has almost nothing in common with the rest, not because it burns differently or shines differently, but because it remembers a version of the universe from before. Almost everything else you can see was even built